class. Today is Wednesday, May 27th. This is Coronachem day 37 for period 4. Your homework last night was problem number 1455, where we're going to use Arrhenius law to solve for the activation energy of a chemical reaction. Here is the question.
The rate of the reaction, I think it's ethyl acetate being hydrolyzed by hydroxide ion to produce acetate anions and ethanol, was measured at several temperatures, and the following data were collected.
The data are here. This is the temperature, and this is the rate constant for the reaction based on the temperature. So you see that the reaction tends to speed up. The rate constant gets higher as the temperature gets higher. So what are they asking?
Using these data, graph ln K versus 1 over T. Using your graph, determine the value of the activation energy.
So what I did is I took the temperature and I converted it to the absolute temperature. Then from that number I took the reciprocal, which is 1 over T. So I entered this number to my calculator and pressed the 1 over X function, or to the -1 function. So take the reciprocal of that number to get this number, which has units of K to the -1. Remember, the temperature always has to be at the absolute temperature scale. And I took the values of the rate constant and I took the natural log of them to give these numbers. So I plotted ln of K over here, 1 over T on the X axis, and the result was a straight line. I took the slope of that line. You can take a perpendicular and measure the top and bottom values. You can also obviously write your graph paper as big as you can. Use as much of your graph as you can to get the best, most accurate drawing that includes all the points. Maybe even consider going beyond, extending beyond the points to get a better slope from the data. Because if you draw your graph very small, the tiny variations in your drawing can result in your value of the slope being off. If you do it by computer, even better. But I think, I'm not advocating you use a computer to do this. I think it's better if you do it by hand, because you gain a better understanding of what's going on. From the slope, delta y over delta x, the change in the y values versus the change over the x values, rise over run. These are the numbers entered. You get a slope of negative 5,276. Now the slope of this graph is going to be the activation energy divided by the gas constant R. And when I plug in those values when I transpose the R to solve for EA, to isolate EA, I got a value of 43,900 joules, or 43.9 kilojoules. Just be careful with the negative signs. It's easy to overlook one and end up with an exothermic versus an endothermic, or an input of energy versus an output of energy. So on this one there's an input of energy, so it's going to be a positive number. If you had a negative number for the activation energy, it would indicate that energy was being released, so you'd be getting a trough instead of a peak. So just be careful with the signs. For today, I'm just going to give you mock test questions. So that concludes our homework for today. I'm not going to teach you a long class. I'm just going to ask you to try the following questions for your mock test, and then I will give you tomorrow a complete breakdown of all the questions and how to answer them. And then on today's Wednesday, so on Friday I will give you your test, and I'll give you the whole weekend to do the test. So I'll make it due on Monday, 6 p.m. So here's your mock test questions. I chose 4, as usual. And I'm going to parallel the test to the mock test. So if you can do these questions, you should be okay. Okay, and I will give you the answers tomorrow. See you tomorrow.